Okay, guys, so today we'll understand what is networking. We'll understand it from first principles and with multiple examples. Okay, so I've already made this structure. Actually, I recorded this video for the first time, and that video was just crap because my computer started lagging a lot. So I have to now re-record this video. Okay, whatever. Let's begin. Suppose this is the person, this is the client, this is Rohit, this is me, and I want to talk to YouTube server. I want to get the data from YouTube. YouTube is my favorite website where I go and scroll the shorts. So I want to talk to you. So what basically happens when I type youtube.com? What basically happens behind the scenes? Behind the scenes in the world of networking. So what happens is, how is the network basically set up? So what I'll be having is like my computers, let's say this is Rohit, will be connected to one switch. Then that switch will be connected to one router, and that router will. This is I have done a basic diagram only, but in real world the scenarios can be more complex. So this router can be connected to n number of other routers, and after that one of the router will be connected to the switch of network, and from there the YouTube server will be connected. So that's how basically the network is connected. So what happens is, the very first time when I type sorry the very first time when I type youtube.com, what happens is like I want to know the IP address of youtube.com. I don't know what this fancy term youtube.com means. Neither my switch knows nor my router knows. No one knows. How would they forward my request? What they'll say, like, I don't know what is youtube.com. Tell me what is youtube.com. So what happens is, suppose this is the packet. This contains this. I want to fetch the youtube.com. It'll come to this switch. Now the very first time I don't have anything. Like, what? Okay, first of all, this switch is a layer 2 device. What is layer 2? Layer 2 is the data link layer. This works, and this data link layer only works with MAC addresses. They only understand MAC addresses. So how the structure of switch works is like, they have a CAM table. What they have? They have CAM table. CAM stands for content addressable memory. It is basically a mapping of MAC addresses and the port numbers. What is this port number? This is not the software port number. This port number means the physical port numbers, what the switches have. You have seen those RJ ports, right? Those are the port numbers. So what this switch will have is like, for this port, this is the particular mapping of MAC number and all those things. So this is the kind of mapping table they have. So when the very first time I send the request for youtube.com, behind the scenes, what will this packet will go to? This packet will go to my DNS server for resolving it to a IP address. How will now, even for going to the DNS server, this switch needs to know the MAC address of my DNS server. But the very first time when I communicate, my switch will not be knowing the MAC address of my DNS server. And where is this DNS server? This DNS server will be connected to the same switch. It's either on my computer or within the same network only. This is my DNS server. So the very first time, what happens is, since I don't know the MAC address of DNS server, what when the packet comes to the switch, now what it will do is like it will broadcast whoever the device is connected to this switch, it will broadcast this message to everyone. You take this, you take this, you take this, you take this. Similarly, the DNS will also receive this packet. Everyone will see like whether this resolution of youtube.com to the IP address is the work of this DNS server. Then the DNS will say yes, this is me. Because anyways, the how will it identify basically is like I will be knowing the IP address of DNS server. So even if the packets is reaching everyone, when the decapsulation of packet happens, they'll see the IP address and only DNS server will find out that this is my IP address. After that, it will give me the mapping of like youtube.com has this particular IP address, suppose x.x.x.x. And after getting the IP address, now this it will send the packet back to the switch. Now, after the first communication, switch internally stores all the mapping in its scam table. First of all, its scam table is always empty when the first communication starts. But after that, now it has the mapping like this DNS server's MAC address is mapped to this particular port number. Rohit's MAC address is mapped to this particular port number. So when the packet comes, it already knows the MAC address of Rohit, so it will directly come to Rohit. Okay, now Rohit knows youtube.com has this particular IP address which we assumed x.x.x.x. Okay, now it's time to send this IP address. I want the data from this IP address. So Rohit will again send the packet now with the IP address. Now it will come to the switch again. Now what is the MAC address to where it has to go? I don't know. So it will again broadcast to everyone. At least I am knowing the IP address where I want to go. So similarly, everyone will reject it, but one guy will take it. Okay, the very first thing. Okay, before that, the what the IP address will have is like that this particular this much whatever is in the network will have a IP address series, and what the YouTube servers will have a different IP address series. So I can't directly communicate to this. So what it will do is like it will when I will get the IP address of YouTube, it will basically convert it to the default gateway IP address because it can't directly communicate to the YouTube server. So after I send this packet, the default gateway IP address is of the router. So the router will get it and it will say, yeah, I am having this. So it will decapsulate and then it will find out that the IP address to which, since a router is a layer 3 device, it deals with the network layer, and it'll find out like the okay, the IP address to which this is the IP address, and if for the very first time it doesn't know like to which IP address I want to communicate, this router will also broadcast to all its connected devices and get the there are various algorithms involved like how it forms its router table or IP route table. Then it will using that broadcasting it'll again get the like all the data where exactly is that of this router and the IP address mapping. Okay, after it gets the IP address, it'll say okay that switch the IP range in which you want to send is that side. Okay, so then this packet will go this side. Boom. And here the switch will receive it. It's a layer 2 device. So again, it'll be having this MAC address, Again, from here also, how will it know the MAC address of youtube.com? It can again broadcast and get it. So from here, then it'll know the MAC address after decapsulating. Okay, this is the MAC address of youtube.com. Okay, take this youtube.com. So this is how the packet reaches from my computer to YouTube server. Behind the scenes, these are the 7 layers. The very first layer is the layer 7, which is called the application layer. Here I'll type www.youtube.com. I decide the protocol. Look, okay, I'm going to work with HTTP protocol. So that I get here. Then the packet comes down. Uh, then the packet comes down to presentation layer. Here actually the data format is selected, like what will be the format in they are sending, like the HTML format, XML, JSON format, and all those things. And second, the encryption takes place. Encryption, the most commonly used is SSL. So because of that, this HTTP request is converted into HTTPS. After the presentation layer, we have this. It comes to session layer. In session layer, we basically uh, start the session between the sender and the receiver. So after this three application, presentation, and session layer, actually if you see in TCP/IP model, these layers are like encapsulated into one layer, which is the application layer. And in the OSI model, these are 3 separate layers. That's basically the difference between the OSI and the TCP model. Then after this, the packet comes down to transport layer. In the transport layer, the transport protocol is decided, okay, whether I'll go for TCP or the UDP. Since I'm going to fetch the website content page, so it basically uses the TCP. But if I talk in terms of YouTube, then if I talk about real scenarios, then the YouTube uses both TCP and UDP. Why? Because the TCP is for the web page and all, but when we start playing the video and everything, whenever it starts dealing with the videos, it switches to UDP protocol. So in real scenarios, it uses both, but for convenience purposes, we assume, okay, whatever website we are loading, it uses TCP protocol. Then it also assigns like on what port number are we going to communicate. So since it's HTTPS, so we are going for 443. Then after in this data packet, this layer 4 header is added. Combine this entire packet is known as segment in transport layer. Then from here, it goes down to the network layer. In the network layer, another layer 3 header is added, which is the IP address of source and destination. This is added. Then this entire packet is called packet in network layer. Then after this, it goes down to the data link layer. In data link layer 2 header is added, that is the MAC address. This MAC address we get using the ARP protocol, address resolution protocol, that we saw how the switches get the MAC addresses out of the IP addresses, right? Then after that we have the physical layer. Physical layer constitutes of all the electrical and physical signals and wires and all those things. From here the actual transport begins. After that we saw like it goes to the like from switches to router and the router to switch again. When the YouTube server receives this packet, it first come to the from the physical layer to come to the data link layer and see the MAC address. Oh, this is my MAC address. Okay, proceed forward. Come to network layer. Oh, this is my IP address. Proceed forward, and it'll keep on like removing one header at a time. Then it will come to transport layer. Okay, this is TCP protocol, and the port is 443. Okay, HTTPS. Okay, proceed forward. Then it will come to these 3 layers, which is application, presentation, and session layer. Basically, the application layer of TCP/IP model. It'll like get the request. Okay, HTTPS request. Give me the HTML, CSS, and JSON JavaScript files. Okay, and again from the YouTube server, again this data encapsulation part will begin. Whatever happened on my side, then again everything will happen on the YouTube side. Again this data packet will be formed here, and it will be sent back again through everything they switch to router to switch to Rohit. Now the switch is already knowing the MAC addresses of the what router to send, what is the path to follow. The router is already knowing the IP route table. It is already having the mappings in out IP route table because it already communicated from Rohit to YouTube path. So it is already knowing, okay, Rohit's switch is that side. So if the packet will from here, then it will come here. Then this switch, my switch is already knowing the MAC address of mine, so it will directly come to me. And again, I'll start decapsulating the packets on my side, and I'll receive the HTML, CSS, and JavaScript files in my application layer. And if you ask me on what ports I'll be getting, the port I'll be getting it on is known as an ephemeral port. These are basically used for the applications or any customized applications that I use. Something in 50,000 ranges, 60,000 ranges, or 40,000 ranges, that kind of port number. So that's the entire flow, like basically how the request from my computer goes to YouTube server, and from YouTube server it comes back to my server. So yeah, I guess I have covered everything, whatever is involved in the in the process when the moment I type youtube.com. So that's all. If you have any questions, comment down below. I'll answer it for you. Thanks a lot for watching this video.